In my fourth video on curve sketching, I'm going to look at what we call rational expressions. Rational just means fraction. You have a term on top and a term on the bottom. Now, I'll be talking a lot about asymptotes here, so if you're not familiar with asymptotes, I have a video on asymptotes, which you could probably look at first, because I'm not going to do a lot of explanation about how we find these. If x is equal to -3, we have a vertical asymptote here. As x goes to infinity along this way, you see the powers of the x on top and bottom are both x to the 1. So the horizontal asymptote is just 1 over 1. In other words, y equals 1. So we've got two asymptotes here. We've got the vertical at x equals -3 and the horizontal at y equals 1. The other things we can notice, when x is 2, we're crossing the x-axis because the y value will be 0. And if we let x equal 0, we get the y-intercept, which is -2 over 3. So you can see if you're going through these 2 points here, it's pretty obvious what's happening to the curve. You're coming up along this vertical asymptote through those 2 points and then up just below the horizontal asymptote. And because you're going down on this side of this vertical asymptote, you would be going up on the other side. And that's what this would look like. If it's a single term on the bottom and it gives you an asymptote, if you're going down on the one side, you'll be going up on the other side. Now, in my second example, I've got a lot more going on here. Two vertical asymptotes at -1, x equal to -1, and x equal to 2. These are these 2 lines here. The horizontal asymptote, y equal 1, results from the fact that if you multiply this out on top, you get x squared. And on the bottom you also get x squared, so you have the same power top and bottom. And again, the horizontal asymptote is y equals 1 over 1, or just y equals 1. The x-intercepts you can see from the top. If x is -3 or 4, you will be crossing the x-axis. And we can also get the y-intercept by putting a 0 in for x. If you do that, you get -12 over -2, which is 6. So putting all this together, you see if you're crossing at 4, you must be coming up underneath that horizontal asymptote. Same thing over on this side. And with the y-intercept of 6, you must be coming down and back up through that 6 on the y-axis. And again, if these are single terms on the bottom, if you're going down on one side, you'll be going up on the other side. I wrote this over here just to show you what would happen if you had an extra factor on the end. You see, I took exactly the same thing that I have up here, but I put an x minus 5 top and bottom. Basically, that can be canceled off and you can forget about it, do it exactly like you've done here, but then go back and say, if x is equal to 5, this is undefined, so just go to your curve and put an open circle at the value where the x value is 5. So putting the hole in it is a fairly simple matter, because you can just ignore it until you're ready to do that. In this one, what I'm trying to show here is if you have a square on the bottom, you see you've got a vertical asymptote of x equals -3, but because it's squared on the bottom, you'll either be going up on both sides or down on both sides. To figure out the horizontal asymptote, you notice I multiplied this out, and because I have a higher power on the bottom, my horizontal asymptote will be y equals 0. X-intercept 2 because the top becomes 0 when x is 2. Y-intercept, a little bit awkward, -2 over 9, because when you put a 0 in here you get -2 over 9. So you see the curve is coming up through these 2 points, heading up above the x-axis, coming down on this side of the vertical asymptote, which means it should also be coming down on the other side. Now, there's a little bit more going on here that I should point out. You see here, because this is squared, we're coming down on both sides of it. What's happening over here is because we've come up and we've crossed above the x-axis, and we also know that it's an asymptote. There's nothing wrong with crossing it, but somehow this curve has to reach a peak and then come back and become closer and closer to the x-axis. You need calculus to figure out where this peak is. It's actually around 7. It just goes slightly above the x-axis. But because you've crossed the x-axis here, somehow you have to bend back, because we know that the horizontal asymptote is y equals 0, or the x-axis.